are going to discuss the today's POT, that is find a safe walk through a grid. So we have given a grid that is consist of binary numbers 0 or 1, that will be value, and we have given one integer health, right? And we have to start from 0 comma 0 upper left corner to lower right, that is m minus 1 to n minus 1, and we can move in all the four directions, right? And as as long as health is positive, this integer health is given, it should be positive. And when if the grid is set to 1, it is unsafe, and if we visit to that cell, our health will be reduced by 1. And if we can reach to this target, we have to return true, otherwise we have to return false. So let's see the example. So, so this is given example. In health is given as 1, right? And this is the path, right? And we can reach here. And since there is no one cell in this path, so there is no decrement in the health, and we can reach. So we have returned to. So we see that there is a source, right? And we have to reach, and there is some paths, right? Edges we can go to other cells, right? If we are here, we can go to this cell, or this cell, or this cell, right? So how we move in directions? We make a direction vector that is 0 comma 1, 1 comma 0, and 0 comma minus 1, and minus 1 comma 0, right? So, and if we add to the current I, j, we will get our new, if we add, right, to our I, we will get our new I, right? So, using this is a very tricky, this is a, you will see this in every codes of the Rasta or the cell visit codes, right? So, this is very simple. We will do the Rasta from here. And for the Rasta, you can use set or priority queue, right? So I will show you the code using priority queue. We will take two things. First is the health, right? We have to uh, go with, we have to try to maximize our health through the path so that we can reach there, right? So we standing at the current node, we only took those nodes we which gives us to maintain our maximum health, right? So we will create an mean heap with priority queue, which will keep the uh, actually we have to use max heap to maximize our health, right? So that our health should be the maximum, right? We have to choose the max value, and we will store the I comma j, the cell from where we have came, right? And we will further explore. So let's go and see the code. So this is the code. We have defined the max heap, right, with priority queue, and it's first is the y health minus git. Suppose if it is 1 at this index, so here it will at this index it will be 4, right? Health is given 5, but when you be at the start, since it is 1, it will be minus 1. And if it is 0, then it is no need to minus. So this will handle that case. And this is the direction to vector to move on. And we are popping out the health, and we are updating our answer, right? And we are going through all the four directions, and we are checking if our answer is less than the health we have come from, and the if we are doing read n minus j, if that contains 1, that will be minus because that's the rule. If it is 0, so there will be no effect on that. And if it gives a less value for that path, so we will update in our answer, right? And we will further explore that node. So that is the simple Digasta. And if we reach on the last node, we will return true. And if this whole path ends, and if we could not reach to that part, so we'll simply return false. So this is the very simple code, and you should explore the Digasta like a study question also. This is very typical questions of the Digasta and the graph, where you have to start from one node, one cell to, and you have to reach another cell. So that's all for today.